Hi everyone, welcome to today's video on understanding and calculating slope. So this is our first introduction to slope, even though we did see things related to it when we were talking about proportional relationships. So slope is the way of measuring and describing the steepness and the direction of a line. So slope is really about steepness. So if we're looking at a line, is it going up very quickly? Is it going up slowly? Or is it going down very quickly? Or is it going down slowly? Okay, so that's the general sense of slope. We're going to try to describe lines by using slope. So when we actually want to calculate slope, or the rate of change, we can do that by doing the change in y divided by the change in x. If we write that out in equation form, if we have 2 points, x1, y1, x2, y2, we can find the change in y divided by the change in x, or the slope by doing y2 minus y1 divided by x2 minus x1. And then that's also often called this rise over run, which works out fine. Rise is when we're thinking about what's the change in the y, because y means up and down. And then run is the left or right. It's the change in the x. If that sort of like shortcut helps you, then that's totally fine. I'm not going to focus on that shortcut though, because I think it can be a little bit confusing, because for the change in y, it can be a negative. So it's not actually a rise, it can be like a fall, and then it just doesn't work out as much. So I'm going to try to continue with the more technical language of change in y divided by change in x for any 2 points. Okay, so these are our 4 types of slope. We can have a negative slope, a positive slope, an undefined slope, or a zero slope. The way I tend to think about it is if I read a graph from left to right, like we read anything, I'm going to put a little person at the top of my line, and it's going to be a negative slope if that person would go down the line, like down the hill. It would be a positive slope if that person needs to go up the hill. It would be an undefined slope if that person we'll just say die, right? If you put the person there, there's no slope for them to walk down, right? There's nothing stopping the person, so they're just going to fall straight down and hit the ground. And then it's a zero slope if the person just wouldn't move, or they would just have to walk straight across, right, without any angle. Okay, so the negative steepness going down, positive steepness going up, undefined steepness, not going to work out, vertical line, zero steepness, just have to walk straight across yourself. Hill's not helping you at all. Okay? All right, so we're going to look at 2 examples of finding slope. So first, from our graph, here we have this orange line, and there are 2 points that have kind of been clearly marked on this line, 0, -1, and -3, 3. Okay, so we can find the slope, m, that's the letter we use for slope, I'm not really sure why, by doing the change in y divided by the change in x. All right, so we can do that lots of different ways, but I'm going to try to focus on it from a graph perspective, so just kind of counting the spots, counting the spaces. We could use our equation, y2 minus y1 over x2 minus x1, but I'm going to do that in the next example, so I'm not going to do it here. Okay, so for the first thing, I'm trying to find between these 2 points, what's the change in the y value? Okay, so the y is the up and down. Okay, we can think of it as the rise, but it's going to be a fall in this case. So I'm going to start, I could technically, depending how I wanted to go about this, start at either point, but I think it's going to be better for us if we just start at the leftmost point. Okay, so I'm going to start at this leftmost point. I'm trying to get to this yellow point. To do that, I need to go down 1, 2, 3, 4. Okay, I'm going down 4. So I'm going to represent that as a -4. -4, because I'm going down. Okay, so I'm going down 4. And then I need to figure out my change in y. I need to go right 1, 2, 3. Since I'm going right, not left, that's going to be a +3. So my slope is just that, -4 thirds. Okay, technically I could write that as -1 1/3, but there's really no benefit to doing that. It just makes it harder to graph, kind of harder to understand in a slope form. So there's actually no benefit, or even less of a benefit, to convert it to a mixed number in this world. So I'm just going to leave it as -4 thirds. I want you to note that our slope here is negative. And again, I said that because when I was going from one point to the other, I was going down 4. Okay, so whenever I'm going down, that's going to be represented by a negative number. And then when you're going left, that's also going to be represented by a negative number. But even if we think we have the right slope and we've taken care of the down or the lefts, what's a good idea always is to just look at our line and say, is this a negative slope or a positive slope? So if I look at this line and I put my little person up at the top here, is the person going to go down the hill, down the line, or is it going to go up the hill, up the line? It's going to go down the hill. Guys, when we're going to go down the hill, then just like we had here, that's going to be a negative slope. So we know we're good here when it's negative 4/3. Right? All right, so that's all it is. One thing to note, though, that made this problem a little bit easier in the graph form is that we're just counting by ones along the x and along the y. So if we had different scales and we were going by like ones on the x but fives on the y, which we've seen some examples of, then it's a little more challenging to just count the spaces. So you have to be very careful about the scale. But if we see something like this, where everything's just ones, then it's pretty easy to just count the boxes. Okay, awesome. So now here's an example where we want to find the slope from 2 points, and they're not going to give us a graph. Okay, so they find the slope of the line that goes through 2, 3, and negative 1, 4. Okay, so this is hard to understand. First, let's just discuss the fact that all we ever need is 2 points to describe a line. Right, once we have 2 points, I'm not going to graph these exactly, but once I have 2 points, if I connect those and then I extend it, those 2 points are going to describe the line. So that's a pretty neat thing about lines. Once you have any 2 points, it's going to describe the entire line, and then eventually we could come up with an equation that describes that line. So we don't have a graph of this yet. So what we're going to do is we're going to use the equation for slope, which is, well, it's still change in y divided by change in x, but we can rewrite that with our 2 points as y2 minus y1 divided by x2 minus x1. Because when we're finding a change in y, we just need to find the difference, which means subtraction, the difference between the 2 points. The difference between the 2 y coordinates, and then the difference between the 2 x coordinates. So for a problem like this, what we just have to be careful about is making sure we're labeling our points so we know what's x1, what's y1, what's x2, what's y2. So for my problem here, I have the first point is 2, 3. So I'm going to call that x1, comma, y1. Because 2 is an x coordinate, and 3 is a y coordinate, and that's what I'm going to consider my first point. Okay? And then over here, negative 1, negative 4, I'm going to say x. Negative 1 is x2, and negative 4 is y2, my second x coordinate and my second y coordinate. Now I could actually switch that, which is a fun thing. It doesn't matter at all which point I call my first point and which point I call my second point. But what does matter is that I'm consistent. So for example, if I label 3 as y1, then I can't go and label negative 1 as x1. No, those are on different points. So I have to label the whole point as my first point, the whole point as my second point, or vice versa. Okay, so now we're just substituting this into the kind of general formula that we have. y2 is negative 4, so I have negative 4 minus y1, which is 3. Okay, that's going to be in the numerator. In the denominator, I have negative 1 minus x1, which is 2. So negative 4 minus 3, that is equal to negative 7. As a reminder, when we subtract a number, it's the same thing as adding the opposite. So subtracting 3 is the same thing as adding negative 3. So we get negative 4 plus negative 3, which is negative 7. Important review from 7th grade. And then same thing here for the denominator. Negative 1 minus 2 is the same thing as negative 1 plus the opposite of positive 2, which is negative 2. So negative 1 plus negative 2, that's negative 3. So we get negative 7 divided by negative 3. Okay, that's good, but we want to simplify that. We don't like having two negatives. So we know from 7th grade that when we have a negative divided by a negative, it's a positive. Okay, so this is just like these become positive, and we get 7/3 is our slope. Okay, so that's the process of it. We substituted in the points, we subtracted, and then we divided, and we got that our slope was 7/3. I'm going to quickly plot these points, though, because I have this coordinate plane over here, and see how we can see that from the graph as well. So the point 2, 3 is right here. The point -1, -4 is right here. Okay, so if I'm going to draw a messy line that connects the points, it's going to look like this. I can see right away that this is going to be a positive slope. If I have my person down here, the person would need to go up the hill. So it's good that we figured out that the slope was positive 7/3. And then let's just check this. I'm going up 1, 2, 3, 4, 5, 6, 7. Okay, so that's my rise or my change in y of 7. And then I'm going to go right 1, 2, 3. That's my run or my change in x of 3. So thus it's the slope 7/3. All right, so that's all it is, everyone. Remembering that the slope is a way of measuring the steepness and the direction of a line, and that to find the slope, we can always do the change in the y values divided by the change in the x. Okay, great job, everyone.